Good morning students. In the previous video we studied about logarithmic differentiation. Those who did not watch the video, they can see the description box, link will be given there. Today we'll see second order derivatives of any function or higher order derivatives. If we have y is equal to f of x, then if we differentiate, then we get dy by dx is equal to f dash of x. So this dy by dx is called first derivative of y with respect to x. If we again differentiating, then we get left side dy by dx of dy by dx, okay, dy by dx of f dash of x. So this left hand side, this is called second order derivative of y with respect to x, and this dy by dx of dy by dx, derivative of dy by dx, we denote by d2y by dx square, which is called second order derivative of y with respect to x. Okay, again if we differentiate this function, this d2y by dx square, then we get d3y by dx cube. This is called third order derivative of y with respect to x. The same way you can differentiate, and they're all called higher order derivatives of y with respect to x. Sometimes y1 is also called first derivative of y, y2 second derivative of y, y3 third derivative of y. Okay? If y is f of x, then dy by dx is f dash of x. F dash of x is called first derivative. Then f double dash of x is called second derivative, second order derivative. F triple dash x is called third order derivative. So in this section we will see derivatives of second order derivatives only. In our syllabus we have derivatives up to second order. Okay? So if we differentiate one function once, we get first derivative. If we differentiate that derivative again, then we get second order derivative of y. Like this we can get other derivatives also. Okay? Now let's see some examples. Some questions. We want to differentiate y equal to 3x square plus 5x plus 2. 2 times means we want to find second order derivative of this function. So if we differentiate with respect to x, then we get dy by dx is equal to derivative of x square is 2x, so we get 6x, derivative of x 1, derivative of 2 0. So we get first derivative 6x plus 5. Again differentiating, then we get d2y by dx square. d2y by dx square is second derivative of y, and it is first derivative of dy by dx. So it will be derivative of 6x, 6, it's 0. So second order derivative of y is 6. Okay? Means once whatever we are getting dy by dx, again we differentiate it. That will be second order derivative. See, if we want to differentiate, we want to find d2y by dx square, second order derivative for y equal to x square sin x. So differentiating once, what do we get? Here there are two functions, so apply product rule. So x square as it is, derivative of sin x cos x plus sin x as it is, derivative x square 2x. So you get x square cos x plus 2x sin x. This is our first derivative of y. Again differentiating, we get d2y by dx square. Now here again product rule. So x square as it is, derivative of cos minus sin x plus cos as it is, derivative of x square 2x plus here again two functions there. So 2x as it is, derivative of sin cos x plus 2x as 2 sin as it is, and derivative of x is 1. So what we have? Minus x square sin x plus 2x cos x plus 2x cos x plus 2 sin x. Okay, so it will be minus x square sin x, 2x cos x, 2x cos x will be 4x cos x plus 2 sin x. So this is second order derivative of x square sin x. Okay, in the same way, if you want to find third order derivative, again you can differentiate. Okay, so now we want to find derivative of second derivative of y equal to sin inverse x. So if we differentiate, derivative of sin inverse x is 1 upon under root 1 minus x square. Okay, now again differentiating. So here we have to apply quotient rule, but we know that product rule is easier than quotient rule. So we convert this function in one function only. So we can write this as, we can write this 1 minus x square to the power minus half. Okay, so quotient rule now is not applicable, and we converted this into simple form. Now if we differentiate, so d2y by dx square will be, now it is x to the power n form, so derivative of this will be minus half n into x to the power n minus 1. Okay, but actually it is not x, 1 minus x square. So differentiate 1 minus x square, and its derivative will be minus 2x. This 2 to cancel out, then minus 1 and minus x is plus x, and it is 1 minus x square to the power minus half minus 1 is minus 3 by 2. So this is second order derivative of sin inverse x, or you can write x upon 1 minus x square to the power 3 by 2. So this is our second order derivative of sin inverse x. So in the same way, we can find derivatives of some other function also. Okay. Now we want to differentiate y equal to cos inverse x. We want to find second derivative of y in terms of y alone. Now we want to find second order derivative of y in terms of y, means in this value of d2y by dx should be free from x. There should not be any term in any term of x. Term should be free from x. Everything should be in terms of y only. Let's see. We have y equal to cos inverse x. So one option we can differentiate, or other way, if y is cos inverse x, then we can write x equal to cos y. If y is cos inverse x, then x will be cos y. Now if we differentiating with respect to x, then derivative of x is 1, derivative of cos y will be sin y, but it is not actually x, so we will differentiate y, and whenever any function in terms of y is there, its derivative will have always dy by dx. So from this, dy by dx will be sin y, you can send here to get 1 minus 1 by sin y, or we get minus cosec y. This is value of dy by dx, this first derivative. Now if you differentiate 1 with respect to x, then we get what? Derivative of dy by dx means d2y by dx square. Okay. Now here we have minus cosec y, so derivative of minus cosec y, minus as it is, and derivative of cosec y is minus cosec cot, so minus cosec y cot y, but again there will be dy by dx because it is not actually x. So we have cosec y cot y minus minus plus, and value of dy by dx from first we can write minus cosec y. So what do you know? Cosec cot minus cosec means minus cosec square y cot y. So it is free from x. So second order derivative of y is minus cosec square y cot y in terms of only y. There is no term in x. It is free from x. Okay, this is the one way. Any other way, just you can differentiate. So dy by dx will be derivative of cos inverse x minus 1 by under root 1 minus x square. ठीक है. Then dy by dx is equal to minus 1 upon root 1 minus x square, है ना. We can write 1 minus x square to power minus half. ठीक. Now differentiate. So d2y by dx square, again differentiating, minus minus plus, so you get 1 by 2 into minus 1 minus x square to power minus half minus 1, but it is not actually x, so again differentiating by chain rule. So this 2 to cancel, then you get minus x into 1 minus x square to power minus 3 by 2. ठीक है. So this is the second order derivative, but it is in terms of x. We need only in terms of y. So how to eliminate this y x? So y equal to cos inverse x. So x will be cos y. So this cos y you can put here. X is cos y. From this equation we can find x equal to cos y. Now it is minus cos y. 1 minus cos square is sin square. So minus cos y, sin square to power minus 3 by 2. It will be sin power minus 3, or you can write 1 by sin cube. So 1 sin, if you give to cos, we get minus cot, and sin square will remain, that becomes cosec square y. So minus cot y cosec square y is derivative of y equal to cos inverse x, free from x. So this also you can choose. ठीक है. So two options we have, you can choose any one. Okay. Now if y equal to a e to power mx plus b into e to power nx, then we have to show d2y by dx square minus of m plus n dy by dx plus m and y equal to 0. If y is this, then we have to prove this value is 0. ठीक है. So to show this, we need value of dy by dx, d2y by dx square, and just find these values, first derivative, second derivative, and put their values here and find out. So simplify. Your value should be 0. ठीक है. So let's start. If y equal to a into e to the power mx plus b into e to the power nx, so differentiating once, we get dy by dx is equal to, a is constant as it is, derivative of e to the power mx will be e to the power mx, and again differentiating mx we get m. ठीक है. Plus b into e to the power nx derivative will be e to the power nx, and differentiate nx again we get n. ठीक है. So this is your first derivative, am e to the power mx plus bn e to the power nx. ठीक. Again differentiating, we get d2y by dx square is equal to, its derivative again will be m into e to the power mx, that will give you a m square e to the power mx. Its derivative will be n into e to the power nx, so we get bn square into e to the power nx. So this is our second order derivative. Now we have values of y, dy by dx, d2 by dx square. These values we put in this left side. So now our left side, d2y by dx square minus m plus n dy by dx plus m and y. Now putting these values here, second derivative, a m square into e to the power mx plus bn square into e to the power nx minus m plus n as it is, dy by dx is a into m e to the power mx plus b and e to the power nx plus m and y. Mn as it is, value of y, a e to the power mx plus b e to the power nx. Now it is equal to a m square e to the power mx plus bn square e to the power nx. Now multiply m into this, we get minus a m square e to the power mx minus m into bn minus bmn e to the power nx, then n minus n into this minus a mn e to the power mx and minus n into this minus bn square e to the power nx plus it will be amn e to the power mx plus bmn e to the power nx. Now am square e to the power mx cancel, minus plus bn square e to the power nx, then bmn e to the power nx, bmn e to the power nx, same sign, different sign, same value, same thing here, so we get 0, and that is our right side. If y is equal to a into e to the power mx plus b into e to the power nx, then d2 over dx square minus m plus n dy dx plus mny is 0. Okay, so just find this derivatives and put there and simplify, you'll get your answer. Okay. Now one more question. If y equal to square of tan inverse x, then it will show square of x square plus 1 into y2. y2 means second order derivative of y, plus 2x into x square plus 1 y1. y1 is first order derivative, is equal to 2. Okay. So let's start question. So we have y equal to tan inverse x square. Now if you differentiate with respect to x, then you get dy by dx, or you can write y1, है ना? So its derivative, it is in the form of x square. So derivative x square is 2x, means 2 tan inverse x, but it is not actually x. So again differentiate tan inverse, and derivative tan inverse x is 1 upon 1 plus x square. Okay, this is our y1. Now to find y2, what you can do? Again differentiating, but here we have to apply quotient rule, and product rule is easier than quotient rule. So what you can do? If you send 1 plus x square in the left side, we get 1 plus x square y1 is equal to 2 tan inverse x. Okay. Now we can differentiate. Again differentiating. So here we have two functions. So apply product rule. 1 plus x square as it is, derivative of y1. And y1 means what? dy by dx. So derivative of dy by dx, d2 over dx square means y2. So derivative of y is y1, derivative of y1 is y2. Derivative of y2 will be y3 and so on. So this as it is, it's derivative y2 plus. Now y1 as it is, derivative of 1 plus x square, that will be 2x. So this differentiation of first left side is over. Now the right side, 2 as it is, derivative tan inverse x, 1 upon 1 plus x square. Okay. Now this will send here, cross multiplication will give you 1 plus x square to the power 2, its square, square of 1 plus x square, y2 plus 2x into 1 plus square, y1 is equal to this 2, and this we need square of x square plus 1 y2 plus 2x x square plus 1 y1 is equal to 2. Okay. So without putting these values here, we can find. So one option, we find y1 y2 and put here, or with the help of this only we can reach up to here. Okay. Now if y is given x plus root x square plus 1 to the power n, then we will show x square plus 1 y2 plus x y1 minus m square y equal to 0. Okay. So what we have, y is equal to x plus root x square plus 1 to the power m. It is our y. Now we need y2 and y1. So first differentiating. So derivative of y is y1. Now its derivative. So it is in the form of x to the power m. So its derivative m into x to the power m plus n plus 1, m plus m minus 1, n minus 1. X to the power n derivative will be n x to the power n minus 1. But actually it is not x. So we differentiate this again, and a derivative of x plus root x square plus 1. This again will differentiate. Okay? And it is equal to m into x plus root x square plus 1 to the power m minus 1. Now derivative this, it will be 1 plus, it is root x, and derivative root x is 1 by 2 root x, and x is x square plus 1. The derivative of root x square plus 1 is 1 upon 2 root x square plus 1, but it is not actually x square plus 1. So we will differentiate again x square plus 1. So its derivative will be 2x. Okay? This 2 to cancel out. Then we get here m into x plus root x square plus 1 to the power m minus 1. If we simplify this, by adding this, we get root x square plus 1 plus x upon root x square plus 1. Okay? So it is our y1, but you can simplify this part. Same base is there, x plus root x square plus 1. Right? So its power is m minus 1, its power is 1. So if we simplify this, x plus root x square plus 1 to the power m minus 1 plus 1 means m upon root x square plus 1. Okay? So y1 we got here. Now with the help of this y1 we can find y2, and we can put all the values here and simplify. Or with the help of this y only we can reach up to here. So if we use first equation, you're in first derivative, we can use first equation is y, then x plus root x square plus 1 is what? This is y. So this we can write y from first equation. Okay, and this root x square plus 1 we send here, we get root 1 plus x square y1. Check, because here if we write here x square plus 1, we have to apply quotient rule. So we send here, now we have two functions in the product form. So product form will be easy. There is root, so we can eliminate this root by taking the square both sides. Then we get 1 plus x square y1 square is equal to m square y square. Okay? So with the help of first equation, with the help of y, our y1 is in terms of y. Okay? Then this quotient form we replaced into product form. There was root, so to avoid that root we can take square both sides. Now if we differentiate, then what we have? It is product form. So 1 plus x square as it is. Derivative of y1 square will be 2y1, and derivative of x square is 2x, but it is not actually x. So again differentiating y1, and derivative y1 will be y2 plus, now y1 square as it is, derivative of 1 plus x square, that will be 2x, is equal to m square constant as it is, and derivative of y square will be 2y, and again differentiating y, you get y1. Okay? Now 2 2 2, then y1 y1 y1, all terms contain 2y1. So if we divide by 2y1, we get here 1 plus x square, then y2 plus 2 and y1, eliminate the x and y1 will remain here, then here x 2y1 give, so m square y. Okay? If you bring m square y here, you get, and that we need x square plus 1 y by y2 plus x y1 minus m square y. So this one to show. Okay? So sometime with the help of y only we can reach up to the given result. So first differentiate, and then in this first derivative your y can be applicable, means y we can use here. If yes, then you can use. Then if there is any two terms in the form of p by q, that q can send here to avoid quotient rule. And if it is in root also, then take square both sides, so that root will be eliminated. ठीक है, like this you can simplify. This process will be easier. Or simple way, find derivatives and then put here and simplify. Two options we have. है ना, we can use any one which you feel easier, है ना, ठीक है.